From the last example, we solved this question, and then I stopped at the last part. The last part says, what is the probability of 3 tails? Remember, the probabilities computed in this distribution is the probability of heads. So we don't have a table that computes the probability of tails for us, because the probability of success, which is getting heads, is given, but the probability of failure is not given. So I can compute the probability of failure to answer that specific question. I'm going to do it over here. I'm going to say, since the probability of success is 0.68, that means 1 minus p, which is the probability of failure, is equal to 1 minus 0.68, which is 0.32. Now, I can answer this question directly, or I can create a probability distribution if this is simple for you or simpler for you. I'm going to create a probability distribution for the probability of tails using the probability of failure, which is basically the probability of getting tails. So since we're repeating this experiment 10 times, that means the possibilities for x is either 0 tails, or 1 tail, or 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9, or 10. So I have all of the possibilities here, and I can compute the probability of each outcome using the probability of failure. Remember, this table represents the probability of tails. This table represents the probability of heads. Okay, so here is equal to binomial distribution, since this is a binomial experiment. Binomial distribution of the numbers, I'm going to click on 0, comma, the trials are 10, and the probability is 0.32, comma, false, I don't want it to be cumulative, and then I'm going to go back to the first number and then double click. To answer this part, we want the probability of 3 tails only. I could have just computed this probability using the binomial distribution function, but I chose to create the table so you have a solid steps to rely on. So to answer this question, the probability of 3 is basically this number over here. So the answer is going to be, this is equal to this number, and as usual, I'm going to turn it into percentage and then add 2 decimal places to it. So the answer is 26.44. I hope this video helped you understand the difference between creating distribution probability for the probability of success and creating a probability distribution of the probability of fails, which is the probability of tails in this case. Thank you, and I will see you in a different video.